Okay, so for this example, we're going to talk about standard deviation, which is a measure of spread of our data. So these two diagrams demonstrate different kinds of standard deviation. So whenever your standard deviation is low, your distribution, if you have a normal distribution, it's going to be really, really tightly clumped and very, very tall. Whenever you have a big standard deviation, you're going to be more spread out and you're going to be shorter. Okay? And again, the symbol for standard deviation in our calculator looks like a cherry or an apple, however you want to think about it. So that's the symbol for standard deviation. So in number 7, we're talking about a survey that was given to all students about their heights. So students are divided into 2 groups, male and female, and we've graphed a histogram of the heights separated by gender. We found that the distributions are normal. That means they're symmetric and bell-shaped. The male heights are similar to each other, but many of the female heights are different from each other. Additionally, the average male height is greater than the average female height. Draw a sketch of the male and female height distributions. So I'm going to get started by just drawing my axes here. Notice that no numbers were given in this problem. We're just trying to infer shapes and properties of these distributions. So the first thing I know is that that I'm going to work with is the average male height is greater than the female height. So I'm going to pick 2 points. On the less average, is that going to be my female curve or my male curve? Which one is going to be farther to the left?
Female.
Female. Females are less than males. So females are going to be to the left. Males are going to be to the right. And I'm going to look, zoom in on my females. So the females have, they're very different from each other. So whenever they're different from each other, the standard deviation, is it going to be big or small? Big. Big. When they're different, so whenever they're very different from each other, that implies standard deviation is large. So if I refer to the diagram up here, a large standard deviation means that they're going to be really spread out. So the females are going to be kind of shorter and more spread out. Okay? The males are similar to each other. So whenever they're similar, standard deviations, whenever they're similar to each other, the standard deviation is going to be small. So it's going to be kind of a tall, pointy curve. Okay? So that could be a sketch of those 2 distributions.